This related rates problem says that the length of a rectangle increases at a rate of 4 centimeters per second, while at the same time the width changes in such a way that the area is a constant 100 centimeters squared. Now the question is, at what rate is the perimeter of the rectangle changing when the side length is 10 centimeters? Okay, so let's take a look at what it is we know. Okay. Now, first of all, take a look at our rectangle here. It helps to have a drawing, particularly when we're talking about shapes like this. So here's my width, here's my length, okay? And we know that the length of the rectangle is increasing at 4 centimeters per second. So that's going to be dl by dt will equal 4, and positive 4 centimeters per second because it's increasing. The value of the length is getting larger, so it's a positive value here. Now, at the same time here, the width changes in such a way that the area is a constant. Okay, well, we know that area is going to be I was going to do x times y here, but it's going to be length. I'll rewrite that. It's going to be length times the width. Okay. Now, the area is going to be a constant. Okay, it's a constant 100 centimeters here. So we can write right away that that's going to be a 100 centimeters squared. This is going to allow us to figure out what the relationship between L and W here. Now, just to be clear, I'm not entirely sure what we're going to do with that yet. Let's keep looking at what else we're given here. So we know at some point here that we're going to be looking at it at that relationship where the length is going to be 10 centimeters. Okay, now I'm going to look at what I want. What I want out of this question is at what rate the perimeter of the rectangle is changing. So I'm looking for dp by dt. I don't know what that is. And I know that the perimeter here is going to be 2 times the length plus 2 times the width. Okay? All right. So now, let's get a little bit of a handle on this. I want to know what dp by dt is. I'm going to have to take the derivative of this. So let's jump into this now. So I know that the perimeter is equal to 2 length plus 2 times the width. I want dp by dt. So dp by dt is going to equal, now I got to take this implicitly because I'm going to take the derivative with respect to time, and time doesn't show up as a variable here. So the derivative of 2L will be 2 dl by dt. Now I know what dl by dt is. That was given to me in the problem. Now I'm going to get 2 dw by dt. I don't know dw by dt, but I do know that the area is a constant. So we're going to go back to this. This was length times width. I'm going to take the derivative of this term right here, because if I do, I'm going to introduce the dl by dt, and I will introduce the dw by dt, okay, and I'll be able to relate those two. So now, when I take the derivative of this, first of all, the derivative of that constant is going to be 0. And now here, this is going to require the product rule. So the derivative of L with respect to time times W plus L times the derivative of W. Okay, and so now I'm gonna, what we're looking for here, by the way, is we're looking for dw by dt. So I'm gonna bring that over here, and actually I'm gonna just rework this a little bit. So this will be L dw by dt is going to equal negative w dl by dt, and I'll divide by L dw by dt is going to equal negative width over the length times dl by dt. Okay. So now I have an expression for dw by dt that I can plug into my perimeter, the derivative of my perimeter here. So that's what I'm going to do. So first of all, I'm going to leave this right here. I'm not going to substitute the value yet. This is going to be 2 times negative w over the length times dl by dt. Okay, now I'm ready to plug everything in. And when I evaluate that, I am going to get the change in the perimeter with respect to time here. So first of all, 2 times dl by dt was 4 centimeters per second, plus 2 times, okay, in this case right here, we know that the length is supposed to be 10. Okay, what I don't know is the width here. Again, I know that dl by dt is going to be 4, so the part that I'm missing here is that width. But I do know, okay, I do know that the area is going to be a constant 100. So in this particular case right here, and this particular moment of time, the length is 10, and I know that the area is going to be 100, so that means I know that the width is also going to be 10. So I can take that and plug that in, and I will get negative 10 here. So we're going to get 2 times 4 is going to be 8, minus 8. Oh, looks like the answer is 0. Okay, so at that particular moment in time, essentially when this thing is a square, okay, the perimeter isn't changing. Okay, this is 0 centimeters per second. So it's kind of an interesting little scenario here. So what's happening is the length is increasing, but the width has got to be decreasing. And at this point right here, when we hit this spot where the length and width are the same, for that brief little instant here, it stops changing. Anyway, there you go. Kind of an interesting result. I like that.